Hello YouTube family, James Green, Short Series Shenanigans. So, today it's the day after Thanksgiving 2016. Hope you all had a good Thanksgiving. So, today is something, I've showed one other video, little snippets of flywheel turning, and I lost some of the video in some of that in doing those episodes. So, had another opportunity, got a flywheel here, it's off a 460 Ford, and I'm just going to show you how I turn it. Again, with everything, there's always a different way of doing it. We've always done it this way since I was a kid, and every flywheel is going to be a little different. But just so you know, on the Grizzly G0776, you pull the gap, and I've got it over there cleaning up. So we got the gap pulled. I'm going to have you guys sitting back at a distance here. We get the camera kind of set in, and what I like to do, all I've done is I've set up. It's on the 3-jaw, it's held in. Everything's cleaned up. I've checked the back of the flywheel to make sure that everything is square where it's mounting up against the chuck, because sometimes you get flywheels that are over torqued and different things, and where the holes come through, sometimes those areas can swell and bulge, and I'll usually take a stone and just kind of do a quick lap to make sure nothing is out of flatness or square back there, and it's fine. And I usually just kind of wipe off all that little buildup. So it's not too terribly bad, but it does need to be turned. We're just using a CNMG 432, and I've got it set. We're just going to do a real quick slow scratch pass across here, or just at slow, 70 RPM. Our feed rate coming across is going to be, let me see, we're in setting E21, which is going to be let me see here, according to the gear we have in. Okay, 2-1. 1.5 thou per revolution. So it's a slow cut. Every flywheel is different. Sometimes you get hard spots, really bad, and all I've done is just kind of wipe this off a little bit to get the bulk of the dust and stuff off, and the gap is pulled. Trying to put some, because when I get done, I'm going to clean all this up really good when I get done, because it is a cast material, so you have to be real cognizant. Trying to put a bunch of rags around there to catch. You can catch ring gear, different things and whatever, but since we got the gap pulled, we always clean it up really good when we get done. And so, just to give you an idea of the diameter of this, you can actually swing something pretty wide in these. So this is a 460 Ford. It is just the flywheel surface. Well, even if you got to the ring gear, we're like 15.5. That's just approximate. So we've got a lot of surface to cover, and I'll just kind of show you guys. We'll sit back. This will be kind of a lot of watch the machine run, listen to it. I'm gonna get a little loud. You might hear some, you know, and it usually takes a couple of passes. Some people usually put them on a big grinder and do them. I've always done them like this, and they've turned out just fine. And I always make sure I get a good pattern, so when the clutch engages. So this is actually going to be in a 1-ton Ford dually, big commercial truck, or not commercial, but it's, you know, construction truck. So here we go. We'll get started and enjoy the show. The first one I like to go really slow, so if there are any hot spots or hard spots, you can detect them and you're not flying across there really quick. Some people like to go faster, and this is just how I do it. So this is actually a Kennametal insert, and you can get these at all industrial tool supply. Coming up there, it's getting there. Actually, let's go ahead and switch it over into 2, which that'll take us right from 1.5 to, let's see, 3 thou per rev. So that doubles the speed, which that's still good. That's still a slow rate. Oh, and I've got the lead screw set up to where it'll cut from inside and out. So normally that would be like a left hand. So I've got the lever back, you can see on the lathe. So this is like if you're going to turn left hand, or out to in. I'll zoom you guys in so you can get a close look at what it's doing cutting. Whoop, trying to do this. There we go. It's actually making a pretty good pass. And even at that speed, I'm satisfied with that. You know, when I get done here, all this is gonna this will get slid off and cleaned out. So anytime I get done doing cast iron or a cast material, I'll always clean it up really good. This may actually clean up on this pass, and if that's the case, I just basically get a touch off in the middle, call it good. So we're probably in maybe, I have to measure it, but we're not in there very far. Maybe 5 thou, if that. I'd have to measure it. We'll let it get about halfway through, and then I'll stop with a depth mic. I'll dig a depth mic out and we'll see how deep we're actually cutting. Because that was one of those things. It's early in the morning. It's about 4 in the morning here. No, I didn't stay up all night. I just got up. I went to bed early and got up early. So we go to measure this. I've got 2 Mitutoyo mechanical analog mics. I've got one in metric and one in imperial. So I'll give both you guys the measurements. We'll let it get about halfway through, and I'll give you the measurements in both metric and imperial. So if you're over across the pond there outside the United States and you go by metrics, depending on where you're around the world, you can hear them little hard spots. But it's actually turned out pretty good so far. Sometimes if you get too light of a cut, it won't cut good, and you don't want to obviously go too heavy. You can cause chatter problems. Generally, my luck has been about 5 thou is generally a good pass. Hear that? Ding, 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 ding. Those are hard spots. You hear from the smooth, and you hear it hitting. You can see when it's going by, the discoloration. I'm going to stop it once we're way out here near the edge. I don't want to stop the cut, because if this is a really good cut, I want to stop it out here where you'd like normally bolt on, because then it wouldn't bother me as much. But I'm just going to let it roll like that. We may have one little area that might be a hot spot, I don't know, but we'll just let it roll. If it's going good, don't mess with it. Don't mess with success. Let me back you guys out just a little bit here. I don't know if that was a fingerprint or what, I don't know. Or an extra oily spot. I just took and kind of wiped it down. Good thing about it was generally what causes really bad hot spots on mechanical or on manual flywheels is if you have a rear seal leaking on the engine and it blows a lot of oil, and these things get hot and they bake and blow the clutch out. And those are usually a real nightmare to get the hot spots out of if they've really been abused. This one hasn't. But they were rebuilding the motor and they took the clutch apart and said, yep, we want the flywheel turned. So I'm like, not a problem, bring it on over. You can swing up to nearly a 17-inch part on here. I think it's like 16 7/8 or something like that. if I remember right. But I've turned 460 flywheels, 350 Chevrolet flywheels. I've turned them for 390 Fords, small cars. I don't know if a big diesel one would fit on here. I hadn't tried it. You know, say like off of a 6.9 or a 7.3 or something like that. That might be too big for this lathe, but I've got my carriage closed. I give myself like a 1/4 inch or 3/8, and I keep my tool choked up, and I always like to keep, if I can, it locked in at least 3 studs here, okay, or lockdown screws. Short and rigid is your friend. She seems to be going really good. Going along real good. We'll just let her feed all the way out here. Past the contact area before we stop it and take a measurement for depth, just for giggles and kicks. And what's nice, you use about a CNMG insert. They'll handle the interrupted cut once you're going across the bolt holes. You do not want to attempt high-speed steel on this if you can avoid it. If you have a carbide insert, whether it's DNMG, VNMG, square, you know, the SNMG, the Trigon, WNMG, or this, the CNMG, the rhombus shape, stick with those, or even a triangular. They give better results. Because I've tried years ago using high speed, different grinds, you just can't get, or at least I haven't been able to. I've always had good luck. Even if you have like an old brazed carbide, those work good too. Just use a carbide and you just seem to get there. It's, I don't know, just a better finish, especially if you're hitting hard spots. And high speed steel does not like an interrupted cut, even on cast material. Sometimes you'll be going along, you'll hit a hard spot and it'll just, well, I've even had carbide inserts at times on flywheels that were really, really, really bad. This is actually, it needs to be turned. It's not nightmarish like some I've seen. You don't put any lube because, you know, there is going to be a clutch surface on here, so you don't want any oil. Cut it dry. I suppose if you wanted to, you could put water, straight water, but we're not running fast enough, and that carbide insert will handle this. It's a soft material, and the lubricity in the metal allows it for it to be cut like this. And remember, size matters. That's today's coffee mug. We're doing along real good there. Back you guys out a little bit here. Now you notice the further out you get, the more it wants to try to seam. That's why I always start cutting from the inside out. I've always had better luck. Because the further away from the center you get, the more things will try to create a chatter. Plus it's a higher pitched ring now. We're further out. We're ringing the bell. That's what the old man that used to, the old millwright that taught me how to do this. He'd always say, you're ringing the bell, watch that chatter. In anything, if it's, you can hear that high pitch. And I did lay a straight edge across this before I started. The face of this is warped. there is some warpage in the flywheel. I didn't set and gauge it. I just threw a flat edge across it, and yep, the flywheel was warped. By how much, I couldn't tell you. We'll be able to tell approximately, just kind of guess, but it was definitely warped. I guess I could have thrown an indicator on here, but, you know, I just like to throw it on, get it done, so the guy can build his motor. I don't know if he's going to start building it today, or actually, the motor's already built. That way, he can start putting this in. The amount of material we started removing in the inside versus the outside is going to vary, because this thing was actually, how would I describe it? It was high in the center, low in the middle, and high on the outside, and there was like because I checked it like in 3 or 4 different areas, and it had some weird warpage to it. It had been ground previously or whatever, but that doesn't mean this thing, you know, you always checking to make, and see it's not ringing as much now. It got past all the hard spots, and it's back to a real nice, that's when you just listen to everything. You can hear, you don't have that high-pitched ring. That was near the end of the face where the clutch disc set. I'm going to let it come out here nearly to the end. I can tell by looking at the cut, there's quite a bit, and we'll measure it, but I'm going to wait till we get way out here to the end before I measure it. That way, if I restart out here and it looks kind of weird, you know, it's not a big deal because it's past the bolt-in area. It won't affect the clutch. I just like it to look really, really, really good. Normally, if I wasn't videoing it, I wouldn't worry about it. But we'll measure it. And I can tell by looking at the cut area here, you can see, I'll even move the camera here and you guys can take a look. I'll try to get you in frame so you can see what I'm talking about. Pardon me while I move the camera. You could look at the far side down there. Like down at the very far side, just above my fingernail, you can see the variation in the width. You can hear it starting to ring a little bit. I'll move you guys over here just a little bit. And before I get carried away moving stuff, I'll actually come over here with the vacuum so I'm not getting stuff up under the carriage. The only place where it is here on the cross slide in the compound. It's actually taking a heavier cut now to the outside, but I know that that back is straight and smooth because I checked it where it's mounted, where it mounts up to the flywheel. Who knows, it might have not been machined correct the last time, or it might have warped. There ain't no telling. Obviously there's warpage. You can tell when it's a heavier cut and lighter. We'll wait till we get out here to the edge before we stop it. That might be the only cut we need to take. And then I'll go back with a conditioning disc and we'll dress it up, because we don't want it too aggressive. We're doing a slow feed, and we don't want it we don't want to turn it into a file to where it grinds the clutch away. That's why we're only going real slow. And we are going 70 RPM. Don't need to go fast. Slow and steady wins the race. You can use a 433, 432. You don't want to use a 431, that's too sharp. Generally 432, 43, 433 on cast materials works pretty good. Okay, we're out far enough now, past all the bolts. Now there are a few little hot spots right there. We're going to have to make another pass. Let me throw this in neutral real quick. I don't want to even move my carbide insert, which some people would say, that's a no-no. I'll be alright. So we do have some hot spots. Let me make sure you guys are in frame here where you can see it. Let me move you down here. So the areas where we thought those were thumbprints, those are actually hot spots, hard spots. So we are going to have to take another. Oh yeah, you can feel it and you can see it. So that's what a hard spot looks like, and you can see all through here. The light's hitting it just right. So we are going to have to take another pass, and you could hear that through there. So but that gives you an idea. We're cruising right along. Let's go ahead and real quick for you guys and gals before we run out of time, back this up here. Alright, so the e-stop is in, everything is here. Let's do a quick, this is millimeter, and we'll just get it in a couple areas. We'll do here, let me make sure we're zeroed, and we are up. Okay, so here, 0.9 mil. 0.9 mil, okay, there. And then we'll slip over here to Imperial. Oh. 23 thou. Okay, and then we'll come over here to where I know it's very thin, almost 180, and then we'll measure this. 10.5 thou. Okay, so you can see quite a bit. And then we'll back up here, and right here, 0.31 mil. Alright. I guess it is. Was it? Yeah. Oh. I mismeasured the other one. I was like, that doesn't sound right. 0.46 mil. So you can tell the difference. Again, that's just approximate. We're going to go ahead and continue on here, but that gives you an idea. You guys can see the hot spots. We are going to have to make another pass. We still have a lot of meat on here that should get us past all the bad stuff as to why the flywheel wants to be turned. So anyway, I hope you guys have enjoyed it, and I figure it would make an interesting video there. Again, thank you for watching. I appreciate it. Click the like button down at the bottom, spread the word about the channel. There's lots of videos out there on my channel, you guys and gals, and we'd like to give a big shout out and thank you to All Industrial Tool Supply, one of our channel sponsors, as well as American Rotary and Drill Hog, as well as Big Gator Tools. You guys, go give them a like. Find them on social media, internet sites. I'll post the links down at the bottom. They're good American businesses, and you know what? If it wasn't for companies like that, I wouldn't be able to do what I do. So go give them a look. If you guys have any questions, give me a shout out, eagledustoff37@gmail.com. I'm also on social media at eagledustoff37 on Instagram and Twitter. You guys, I'm always great to have answer any questions. Positive comments are highly encouraged. So if you've done this for a while, you know all the pitfalls of it, and like I said, there's always different ways to do it. And if you're new or you have just purchased a machine similar to this, which I know I've had several people in the last several months contact me and they've bought this, so you have the same ones. Again, I'll give the call outs right here. We were running 70 RPM. We had the lead angle or lead feed, we're running in like you do left hand, okay, like you're going to cut a left hand thread, so we could feed from the inside out. And we're in position E2, and we started out at 1 but it was slow, and position 2, so E22, which gave us about 3,000 revolution per minute, and it ran a CNMG 432 insert. Thanks for watching, you guys. Again, www.allindustrial.com. Go check them out. Got a new website. Call them, request a master catalog, or download the PDF version on their internet site under current sales flyers. Like I say on the end of every video, and I mean it, guys and gals, take care of yourself and take care of family, because remember, at the end of the day, you and your family is all you got. Until next time, get out in the garage and why don't you turn a flywheel? This stuff is fun. We'll talk to you later. Bye-bye.